Hello, my name is Zach Gibbs, and I am a content developer within education services inside Juniper Networks. And today we will be discussing the DiffServ-Aware TE Policing Learning Byte. All right, so let's go ahead and jump to the example. In this example, we have a topology, and I want to point out the network topology on the bottom left. There are 4 provider edge routers, that's PE1 through PE4, and there are 3 core routers, P1 through P3. And with this, we want to establish 2 LSPs that use the MAM bandwidth constraint model. And the first LSP will start at PE1 and go to PE3. And it will be a voice LSP that will be using CT2, will require 2 megabits per second of traffic, and will have a hold and setup priority of 0 and 0. Then the next LSP will also be a voice LSP that goes from PE2 to PE4. That's going to also use CT2 and will require a reservation of 1 megabits per second, and will also have a setup and hold priority of 0 and 0. And then if you know anything about DiffServ-Aware TE, you'll know that the DiffServ part of it doesn't inherently enforce those bandwidth reservations. It knows how to take the reservation, but it doesn't really know how to hold the reservation. And so how that's going to work is we need to do something to prevent the P1 to P3 voice queue from being overwhelmed. That link between P1 and P3, that's the shortest path through the network. We need to do something to stop that from being overwhelmed. And you might guess at this point that what we're going to do is we're going to do some LSP policing to stop that from being overwhelmed. Okay, so the other thing I do want to point out is that I have artificially decreased the bandwidth on these links to 10 megabits per second. And the reason why I did that is because we're going to be using ping for generating traffic, and it's really hard to generate a gig of traffic or anything close to that when it comes to ping traffic with a Junos device. So just keep that in mind. Junos devices aren't really meant to, as traffic generators. They're meant as routers and firewalls or whatever else. And so, so anyhow, I've artificially lowered the links to 10 megabits per second. And so we can see the queue being overwhelmed without policers, and then we can show policers helping in the situation. Okay, so then the bandwidth reservations for the different CTs, I also want to point that out. CT0, 1, 2, and 3. Now, we're not going to be messing with CT0, 1, or 3. We're just going to be focusing on CT2 that these voice LSPs will be a part of. But I did list the other CT bandwidth reservation information just for completeness sake. And so the CT we're concerned with is CT2. We can see that has a total of 3 megabits per second. We can see between the 2 LSPs that we have 3 megabits per second total. And so we should be fine with using that one link as far as the setup reservation. So keep that in mind. So let's go ahead and jump to the CLI and get this going. All right, here is the CLI. We'll be primarily working with PE1, PE2. And we also have sessions open with the VR device, which houses the P routers, and also will generate traffic from the CE routers that are also logical systems. That's not on the topology, but we'll generate traffic using the VR device. So we'll have a couple sessions open for that. All right, so let's go ahead and get started. And something else before we get going, I do want to point out is that the class of service configuration is already taken care of. I don't want to take the time in this Learning Byte to go through that because we don't have the time to do that, but it's already taken care of with those reservations that we saw on the slide with the different CTs. Okay, so with that, let's jump into configuration mode. You can see here that we do have some DiffServ configuration information already there. Now, this is what's in place on all the routers, because with DiffServ, you need to have all the routers within the MPLS domain to have the same DiffServ general configuration. So this will be the same on all the different routers. So let's go ahead and set up some label switch paths. First one is going to be PE-1, PE-3 underscore voice. That's going to be our voice LSP for PE1 going to PE3. That's going to be going to PE3. So we need to type in the information for PE3. That's the loopback address for PE3. And then we need to set the, actually want to set the priority first. It's going to be 0, 0. And then we can set the bandwidth information. CT2, this is going to be 2 megabits per second. You see that is the configuration. Let's go ahead and commit that. Now let's jump to PE2. So here is PE2. You can see a similar configuration of what we had on PE1. Now we need to set up that label switch path. And it's going to PE4. Type in PE4's IP information. Set the priority 00, and then need the bandwidth information CT2, 1 megabit per second. Let's go ahead and commit that configuration, and then we'll jump back to PE1 and examine, see if the LSP is up. It is. Let's look at the detail information, make sure it's going over the shortest path. We can see that it is. It's using that 172.16.10.2 as the second hop. That is the address for the P1 to P3 link. Perfect. On PE2, let's check it out. Type, there we go. Yep, the LSP is up. And you can see here that 172.16.10.2 is the second hop that represents the P1 to P3 link. Perfect. So they're both taking the same link right now. And so if we were to actually look at the TED database, look for the 10.10.10.1, this is the P1 router. We want to look at that link that is going between P1 and P3. And we can see here, we can look at the TE information. And I didn't show you this, but this uses TE4. We see TE4 shows 0 bits per second available. We are taking up the entire bandwidth for TE4, which belongs to CT2. See, CT2 has 3 megabits per second available, but this is something we already know beforehand. So this is just how it's configured with CT2, so keep that in mind. But I did want to show that we are using the bandwidth reservation for that link between P1 and P3. All right, so let's start sending some traffic. This will be sending traffic from the CE1 device that is connected to PE1 to the CE3 device, which is connected to PE3. So let's get that going. We see traffic's flowing. So we just have one source going, so let's go ahead and look at the statistics for that interface between P1 and P3. Let's clear the statistics first. Look at the voice forwarding class. Okay, we can see that traffic is flowing. We're not getting any drops. That's fine. Oh, we are getting a few tail drops there, but we're not getting very much. You can see there's 3 right there. And so you can see that the queue is kind of starting to get overwhelmed a little bit. We're sending too much traffic as is. So let's go ahead and start another stream. This is going to go from CE2 to CE4. You know, CE2 is connected to PE2. CE4 is connected to PE4. Let's get that going. And now we should start seeing some serious drops, some tail drops in that queue. It's jumping up to 8 already. 11. See, it's increasing more rapidly now. That's not what we want. The voice queue is being overwhelmed. We don't want that. You see now it jumped up to 27. Yeah, this is not a good thing. So we are overwhelming that queue. So what we can do is we can configure some policers, apply it to the LSP to stop that. So here is PE1, and we will configure a policer here and then apply it to the LSP. So first we need to go to the firewall configuration hierarchy, and we can go to a policer. We'll call this voice-PE-1. And here we can set, if exceeding, we set a bandwidth limit. Bandwidth limit, we can set 2M. That is the reservation for the LSP. And then we can say set, if exceeding burst size limit. We need to set a burst size limit. We're just going to say 1500 bytes. And we're going to say set then discard. And we're not done yet. We've configured the policer, but now we need to reference it in a firewall filter that uses the family of any. We'll call this PE-1-voice. And all we have to do here is we set a term, call it whatever, then reference the policer. And that's what we have to do there. You see the different firewall configuration that we just configured with the policer in that firewall. Then we go to protocols MPLS, and then we can set the policer here. Policer, reference the filter. We want to reference the firewall filter that we just configured that references the policer. What do we call that? We called that PE1 voice. There we go. Then we can commit that. And then we'll go to PE2 and we'll do basically the same thing except for the parameters that we need for PE2. Call this PE-2 underscore voice. For the policer, set if exceeding bandwidth limit, we'll say 1 megabit per second here, because that's what the LSP is set for the reservation, remember. And we'll set the burst size limit to 1500 bytes again. Set that to discard. See what we have configured there. And we'll call this filter PE-2 voice. Same thing, we just need to reference the filter. So I could type. Or rather, the policer. Sorry about that. I said the filter. I meant the policer. That's the configuration we just configured. And then we need to go to protocols MPLS and set that in the LSP. Remember, we need to reference the actual filter, not the policer. And that's the configuration for that. Let's go ahead and commit the configuration. And then we'll jump to the VR device and look at the queue usage. Okay, so let's clear the statistics on the VR device. The interface statistics, that is. And then we can look at the voice queue for that interface. And we can see here that we're not getting tail drops. And we can wait a little while here and keep examining the queue. And we'll see that we won't get tail drops because those policers are doing their work. And I think we're good on checking that there, but we can do one last thing. We can come back here, look at the firewall output to see the policers, and we can see that packets are being dropped. We see that we have bytes and packets matching the policer. And when it matches the policer, that means it gets discarded because that's how we configured it. Now we could do other things such as changing the loss priority, changing the forwarding class, to change the quality of service or class of service on that traffic that is out of profile. But with this, we're just dumping it into the bit bucket. And on PE2, we can see the same thing. We can see that we have packets that are matching the policer, and those packets are being discarded. So that brings us to the end of this Learning Byte. In this Learning Byte, we discussed how to configure DiffServ-Aware TE LSP policing, and then we demonstrated how to verify that policing. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.